All right, so I think I'm recording. Let's take a look at this problem. In problem number one here, it gives us functions f and g, and it asks us to use these two functions in parts a, b, and c to build a new function, to build new functions. And then in part d, we're asked to find the domain of each of these new functions that we built. All right, so this notation, this is just a title, fg of x, but it's a very clever title because it tells us how to build this new function. We build this new function by multiplication. So we're going to take f of x, and I'm going to go ahead and factor that denominator now because it's easy to see that it factors. Because when I'm multiplying these two together, oftentimes with ratios, since you always want to give your final answer in lowest terms, it's often easiest to cancel common factors as quickly as you can. So we see that we have in the numerator a factor of x plus 3, and it's being divided by a factor of x plus 3, so those divide to 1. And this product is 1 over x minus 3 squared. So that's this new function. And in part D, it asks us to find the domain of this function. And this is where you have to be a little bit careful, because if you jump in and just go off of that final result right there, then you're never going to recognize that this would not have simplified to this fraction if x was allowed to equal negative 3. So rather than finding your domain from the expression, it is smarter, you'll make less mistakes to find the domain of f times g if we know it was built from two functions, is to find the domain of the individual functions and intersect f and g. So what is the domain of f? The domain of any function is the set of all real numbers, excluding any values that cause division by 0 and excluding any values that cause us to take the square root of a negative number or the even root of a negative. We don't have square roots in this problem, so we don't have to worry about that. But we do have variables and denominators. So in f here, we've seen that in factored form, this x squared minus 9 is x plus 3 and x minus 3. So we have to throw out negative 3 and positive 3 from the domain because they cause division by 0. And if we write this in interval notation, we've got from negative infinity to negative 3, excluding negative 3, to positive 3, excluding positive 3, all the way out to infinity. And if we look at g, it's easier to see even than the f was, that 3 minus 3 gives you 0. So we're going to just throw out positive 3. G doesn't have a problem with negative 3, but it does with positive 3. So the domain of g is all real numbers, excluding positive 3. So whenever you're finding an intersection, remember the intersection is this, translates to this word and, you have to be in both sets to be in the intersection. So I would suggest that you sketch a number line and that you draw a picture for the domain of f and the domain of g and use those pictures to get the domain of f times g. So in red, let's sketch out the set of all real numbers, excluding negative 3 and positive 3. So my sketch for the domain of f would look something like this. And the sketch for the domain of G would look something like this. Like we said, G didn't have a problem with -3. G only has a problem with +3. Well, what we want to do now is to sketch this intersection. To be in this set, you have to be in both sets. Well, to the left of -3 is shaded here. To the left of -3 is shaded. So to the left of -3 is going to be shaded in the intersection in my final answer. -3 is not shaded. To be in the intersection, you have to be in both. -3 is not in both. -3 is not shaded. And +3, for the same reason, is not shaded because it's not in either one of those sets. But all of these numbers that are between there are in both sets. So they're in the intersection. And all of the numbers greater than 3 are in both of these sets for the domain of F and the domain of G. So they're in this intersection. So it turns out then that the domain of F times G happens to be the same as the domain of F, which is all real numbers excluding -3 and +3. But that may not always be the case, you know. And I would suggest, until you get used to intersecting sets, that you draw pictures and look and see, to be in that final answer, it has to be shaded in both of the above sets. All right. So let's erase this, part of it anyway. And let's find the expression for F over G, and then also find its domain. All right. So to build this new function, the title of this is giving it a way of how to build it, and that is, if they would have just called it something like H, I wouldn't have known that H is obtained through dividing these. So it's very clever how they've named this new function, because it tells me to take f of x and divide it by g of x. Now remember that this fraction bar, this is not the only way that I have to denote division, that I could write f of x divided by g of x. And I'm going to choose to write it this way, and I think you'll see why in just a second. For f of x, I know that's 1 over x plus 3 times x minus 3. And for g of x, it's x plus 3 over x minus 3. Writing division with this symbol, in my opinion, helps students to remember how to divide complex fractions. That division is the same thing as multiplying by the reciprocal. The reciprocal, if I change this division to multiplication, I have to flip this fraction. And now I have a factor in the numerator and the same factor in the denominator, and those divide to just 1. So when I multiply straight across the numerator, straight across the denominator, I get 1 over x plus 3 quantity squared. And that's how I would leave my final answer. But I know there's going to be a lot of people that will multiply it out. See, the directions didn't say that our final answer had to be in any kind of specific form. So it's perfectly acceptable to, as your final answer, have 1 over x squared plus 6x plus 9. So either one of these is okay for this new function f over g. Now, to find the domain of f over g, it's getting a little bit more complicated. We start out in the same way that we did for part A, and that's it. That's why I didn't erase this domain of f and domain of g, is we're going to take the domain of f and intersect it with the domain of g. And that's the same as what we did in part A, but we also have to be concerned if g of x, is there a possibility that g of x could ever be 0? And if it is equal to 0, we find the values of x that cause that and throw it out of the domain. So when we look at g of x, we know that a fraction reduces to 0 if the numerator reduces to 0. So I can look at this and I can see that when g is -3, when we evaluate g at -3, when x is -3, that I have 0 divided by -6, which is just 0. Well, I can't allow that to happen. So I have to throw out -3 from the domain. But if we look at f and g, -3 is already thrown out. So it turns out that it's the same answer as our answer for part A, and that was all real numbers excluding -3 and +3. So yes, it was possible that g of x, that this g could be 0, that the values that caused that to be 0 were already thrown out of the domain because of the domain of f. So anyway, there's our domain for part B. Let me erase this and we'll do the domain for g over f. We'll find the expression and do the domain. And see, it's better. I know it's more work, but you're going to have situations where you'll get the wrong answer if you try to jump in and use that final answer for f over g. You have to consider how it was built when you're finding the domain. So in part C, you know what? I'm going to undo the thing that I just erased. Hopefully it'll undo it. Yeah. When I look at B and I look at C, they're reciprocals of each other. F divided by G and G divided by F are reciprocals of each other. So it's very easy for me to get the answer for part C by using my answer from part B. I'm going to erase this part of it anyway. If you ask me to find the equation for this new function, I would divide g divided by f. But I already know what f divided by g is. I know that it's just the reciprocal of my answer in B. This 1 over x plus 3 squared, if I flip that, it's x plus 3 squared over 1. Well, I don't have to write divided by 1. And if you wanted to, you could multiply it out. So oftentimes, when they're asking you a series of things, A, B, C, D, don't reinvent the wheel. Use your answers from parts A, B, and C to sometimes help you get answers in C and D. Don't throw away that previous work because it can help you, especially time on a quiz or a test, that you're not starting all over. Now, we do want to find the domain of this. And you would be tempted if you look at just the function itself and not think about how it was built, you would say, well, the domain is all real numbers. I don't have a variable in the denominator and don't have a square root, but you would be wrong. We have to consider how it was built. So we have that same consideration that we did last time. We want to intersect the domain of f and the domain of g, and we want to make sure that the denominator is not 0, that you can't, f of x, you can't have division by 0. So is there any value of x that will cause f to equal 0? Well, no, because if we look at f, that numerator is constantly 1. If you have a fraction and that fraction reduces to 0, it's because the numerator is 0. If the numerator is never 0, then that fraction is never 0. So I do not have an additional restriction. F in the denominator, I don't have to worry about it. Even though I have a variable in the denominator, I'm never going to have division by 0. So my domain for all three of these are the same. My domain for g over f happens to be, and this isn't always going to be the case, the same as our previous answer, which was the same as the domain of f times g. But we didn't know that going into the problem because we didn't know if these denominators would have made us make this domain more restrictive. So hey, I hope that helps, and I'll talk to you later. Ask me any questions. This stuff is a little bit more difficult than some of the other things that we've seen. Talk to you later. Bye.